Hi Math 2, this is Unit 6, Lesson 7, and today we're going to begin to talk about parabolas. So for the last 3 lessons, we were talking about circles, and so for the next 2 lessons, we're going to talk about parabolas. Parabolas are also on our formula sheet, and if you haven't printed it yet, there's a very useful Unit 6 formula sheet in the locker, and I'm going to be using several formulas from it today in our lesson. So first of all, in this notice and wonder, let's take a quick look at this. I've had students tell me from my other courses when we were still in school, they noticed a lot of interesting things. They noticed, first of all, they thought it looked like a spider with a central part of his body and all the legs. I thought that was pretty creative. They also noticed that the dotted lines appeared to look congruent. For example, this dotted line and this dotted line appeared to be the same distance. So I had the students connect them. Some students were noticing this U shape being created right here. So go ahead and connect these dots, all the dots except the F dot in the middle. And that creates our U shape of a parabola that you might remember from algebra last year. So in this picture, I have my parabola. And my parabola is made up of a bunch of points that when I join them all together, they create this parabola shape. And this F right here we call our focus. And this blue line is called a directrix. Both are very important for my parabola. So my parabola's vertex, if you remember last year, the vertex is the min or the max, depends on which direction my parabola is facing. The vertex is, we're going to discover halfway in between my blue directrix and my point F, the focus. So we'll be talking about that today too. And this is creating my shape of a parabola. So again, I'd like you guys to notice my dotted lines. The distance from my focus to this point is the same as the distance from this point to my directrix. And if I could get another color, again, the distance from my focus to this point is the same as this point down to my directrix. And if I could get another color, this little teeny tiny distance is the same as this distance right here. And coming to the other side, this distance from my focus up to this point is the same as the distance from the point down to the directrix. So all of these distances on my parabola are looking congruent. So we're going to use this to help us write a definition. A parabola is the set of points that are equidistant from a given point called the focus and a line called the directrix. This definition looks a lot like a circle definition, where we defined a circle to be the set of points that are equal distance from a given point, the center. So this is similar wording, except it's not a given distance from one point, the center. It's a given distance in between the focus and this line called the directrix. So let's take a look at the distance between the focus and the directrix is equal. Different parabolas. So some things I want you to notice is that in every single one of these pictures, I have a focus and I have a vertex on my parabola and I have a line. This blue line is my directrix. Happens to be the x-axis in all of them. So notice that these three are in all of these graphs. So for example, the bottom one in the middle, I have my directrix, I have my vertex, and I have my focus. So let's take a little bit and look at these 6 pictures. So in this picture, let's take a look at the focus and the directrix and the shape of my parabola. So some of these parabolas are very narrow and some of these parabolas are much wider. So let's take a look at a narrow parabola. Look how close my focus, let me get my yellow here. Look how close my focus is to my directrix, and it's very narrow. So let's take a look at the picture next to it. Look how much farther away my focus is from my directrix, and my parabola is wider. So let's take a look at another one that's a bit narrow. This is 2 units in between my focus and my directrix, and it's more narrow. It seems like the closer the focus is to the directrix, the more narrow the parabola. So let's take a look at a really wide one, the third graph. If you notice, it looks like my focus, and my focus is up at y = 5. And if you count down 1, 2, 3, 4, 5, 5 units between my focus and my directrix. And it makes my graph wider. So in this case, it looks like the farther, so I'm going to write this one up above here. The farther the focus and the directrix, the wider the parabola. Okay. So those two pieces of information certainly go together. So now let's see why our parabolas seem to be upside down. We have two pictures. We'll call these 1, 2, so we can talk about them. This will be picture 3, 4, 5, and 6. So pictures 4 and 5 are pointed downwards. That means it opens down. It has a max in my parabola. And so taking a look at those two to notice what's the difference between the other 4 graphs, it looks like the focus is under the directrix. And that's causing my parabola then to point downwards. Okay. So then let's look at the last question. It says the vertex of the parabola is the lowest point on the curve if it opens upward, or the highest if it opens downward. Where is the vertex located in relationship to the focus and directrix? So in the first picture, my vertex is my black dot. The second picture, it's my black dot. And in the third picture, it's my black dot. And then in the fourth picture, let me make it larger as well. So it looks like in all 3 of those pictures, my vertex is in a specific location compared to the focus and the directrix. What is it looking like to you? That it's halfway in between? So we can say that the vertex is the midpoint of a segment drawn from the focus to the directrix. So it's halfway in between. That's going to be useful in one of our practice problems. The previous page and take a look at this one. So my focus is at 2.2. And my point is at 6.5. So the first question asked, so let's count. It was 1, 2, 3, 4, 5 units from the directrix. So basically, to find how far your point is from your directrix, you just want to find that distance between the directrix and your point. So it was 5 units. So if that's the case, then I know that my focus, and my point also has to be 5 units. Now I can find that using my distance formula. Let's remember the distance formula. The distance formula is on our formula sheet I talked about earlier. It's the difference in my x's squared plus the difference in my y values squared. So in this case, let's write down the 2 points I'm using. I'm using 6, 5, and I'm using 2, 2. Let's see if I can use my distance formula and get an answer of 5. I think the distance should be 5, so let's see if I can find that to be true. So the distance between the points, let's take my two x coordinates, 6 and 2. It doesn't matter which one you use first at all, so I'm going to use the 2 first. So I have 2 minus 6 squared plus the difference in my two y values. So I'm going to do 2 minus 5 squared. So that looks like it's giving me 2 minus 6 is negative 4 squared. 2 minus 5 is negative 3 squared. When I square those numbers, I get 16 plus 9, and then I'm going to get the square root of 25, which is indeed 5, and that's the answer I was trying to get. So again, the distance, and this is going back to the very first page of our, so coming back to this problem, I've shown that the distance from P to my directrix is 5, and P to my focus is 5. Let's take a look at the next page. So let's take a look at the top. It says on the final image, the directrix is on the x-axis, and the focus is the point 2, 2. It says, what's the different distance between the point P and the directrix, and what does this tell you about the distance between P and the focus, or F? So let's go back. The first question asked, how far was P from the directrix? So let's just put that in here. The distance was 5 units, and I calculated the distance to also be 5 units. My work is on the previous page, which is page 53. Okay, so it says the image shows a parabola with focus at 6, 4. So this coordinate is 6, 4. And the directrix is at y equals 0. That's the x-axis. The x-axis has an equation. It's a horizontal line, and its equation is y equals 0. So it says the point 11, 5 looks like it might be on the parabola. Let's find that. 11, 5 is a point up here. This is the point 11, 5. It might be on my parabola. It says determine if it really is on the parabola. Show or explain your reasoning. So let's use this distance formula and the idea that the distance between my focus and my point, and the distance between my point and the directrix should be equal. So let's find the distance between my focus, which is 6, 4, and my point, which is 11, 5. So we're going to find that distance first. So my distance formula, the difference in the x's, so that's 6 and 11, 6 minus 11 squared, plus the difference in my y values, that's 4 and 5, 4 minus 5 squared. That equals, well, 6 minus 11 would be negative 5 squared, plus 4 minus 5, which would be negative 1 squared. That looks like I'm getting 25 plus 1, or the square root of 26. I'm not sure what that is off the top of my head, but I'm going to leave that there. You could do that on your calculator if you wanted to. And if you don't have a scientific calculator at home, if you take your phone and you go to your calculator app and you turn your phone on its side so that your phone is horizontal. So if you go to your calculator app and you turn your phone so it's horizontal, you should see lots of new function keys. You should see your tangent, cosine, and sine that you're used to. You should also see a square root button. You should also see a cubed root button. So if you're having trouble accessing a scientific calculator in some way at home, make sure you ask about that in our Zoom session so I can help you, whether it's on a computer, an iPad, your phone, wherever I have access to a scientific calculator. So back to this one. So now let's find the distance between our 11.5, our point, and the directrix. This is generally just a counting activity. So this is the one that's in red. So I'm counting 1, 2, 3, 4, 5 units. So I get 5 units. Well, the square root of 26 does not equal 5. So no, this point 11.5 is not on the parabola. Basically because the distance between the focus and the directrix didn't come out to be the same value. So let's try this whole type of thought problem again with number 2. Number 2 said the point 1410 looks like it might be on the parabola. So let's go find it. 1410 is up here. I'm going to do it in green. And it says determine if it's on the parabola. Okay, so let's find the distance between 1410, my point, and my focus, 6, 4. So I'm going to find this distance first. So I'm going to use my distance formula between these 2 points. So the difference in my x's would be 14 minus 6 squared, plus the difference in my y's, which is 10 minus 4 squared. So this looks like I'm getting 14 minus 6 is what, 8 squared, plus 10 minus 4, which would be 6 squared. So I'm getting the square root of 64 plus 36, which I believe to be 100. So the square root of 100 gives me a distance of 10. So I know this green distance is 10. So let's find now the distance between my point, which is 1410, and the directrix. Again, that's just really a counting activity. So let's count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that would be 10 units. Since I got 10 for both of those, then yes, my 1410 is a point on the parabola. So in general, how can you determine if a particular point is on the parabola? Find the distance between the point and the focus, which is what we use the distance formula for. So I'm going to write that in right here. I'm going to subtract my x coordinates and square them and subtract my y coordinates. And order doesn't matter because you're squaring them. And then I'm also going to find the distance between the point and the directrix. And you want to compare them. You want to see if those are the same. Are they the same? Are they equal? If they are, then it's on the parabola, and if they're not, then it's not on my parabola. So let's take a look at the, go one more page after this. On this page, I want to highlight some of the things that were really important. So in this picture, my directrix, so this is my x-axis, and it says the directrix is y equals -3. So this is my directrix, y equals -3. And my focus is the 0.21. So the focus is the 0.21. So I want to highlight again the major takeaway is that any point on the parabola is equidistant to the focus and directrix. So let me take a point where I don't really have to use the distance formula. I can just count. So let's take this point, which is -2, 1. So -2, sorry, let me use my eraser to clean that up. Let me go back here. Sorry about that. So negative 2, 1. So this point, let's calculate how far it is from the directrix. The directrix is down at negative 3. So basically it's 1, this is 2, 3, 4 units. So this is 4 units total. So now let's find out how far it is from the focus. So we have 1, 2, 3, 4 units total. So it's the same distance between the focus and the directrix. So then the point negative 2, 1 is on our parabola. And that's true for all of our points. And please read this bottom portion as well. This is going to get us into the equation we'll be learning in the next lesson, our lesson 8. Thank you.